Hello students, welcome to aimsindia online classes. This is chemistry session. Here we are discussing about chemical bonding. In this session we are going to see about ionic bond formation. Before going to see about this ionic bond and different kinds of bonding, we have to know one thing, that is electronic theory of valency. So based upon this, chemical bondings are occurring and how many kinds of bonds are there we are going to see later. First let us see about electronic theory of valency. The electronic theory of valency shows its rise to the recognition of the existence of electrons in an atom. Yes, by this theory, we can understand as electrons are existing inside the atom, and these electrons are responsible for the formation of chemical bonds by the atoms. So it was suggested that electrons themselves are responsible for the formation of chemical bonds or for the chemical combination of atoms. Okay, these electrons are responsible, and particularly to say the electrons present in the outer shell of that atom are responsible for the reactive nature of that atom. Cosell and Lewis formulated a comprehensive statement which was completed by Langor and called electronic theory of valency. So these scientists they have given a comprehensive statement which explains the chemical nature of the elements or how the reactive these elements are. What do we say? Electronic theory of valency. Now let us see here the important points from this electronic theory of valency. First among them is the secret of stability of atoms. So it explains how the elements are being stable. Atoms with 8 electrons in the outermost shell are chemically more stable. So it is observed by the scientists some elements they are being more stable and least energetic too. That means those atoms, the atoms of those elements, they do not participate in the chemical reactions. They do not combine with any other elements, and even they do not combine themselves also. Such kind of elements we are calling as stable elements. So it is observed those all elements they contain 8 electrons in their outermost shell that we call as octet. So the elements which are having octet configuration are being more stable. They are not participating in the chemical reactions. Hence, those all elements which are having this octet configuration are considered as noble gases or ideal gases. Because for this all, there are 8 electrons in the outermost shell and they are not participating in any chemical reactions. They are being idle. So they are called ideal elements. And one more exception is there here. One more element is present with only 2 electrons in its outermost shell, and that is also being more stable as these noble gases. That is helium. That configuration is called as duplet configuration. Elements with a single electron, if they have duplet configuration, they also will be stable. Duplet configuration means having 2 electrons in its first shell. Only in one shell if it is having electrons and it is completely filled with 2 electrons, then that element also will be more satisfied and being more stable. So in that way, except helium means atoms with 8 electrons in the outermost shell, 2 electrons in case of hydrogen, helium, lithium and beryllium are chemically more stable. If they have 8 electrons in the outermost shell, being more stable. Next point is cause of chemical reaction. It is explained here why elements are being more reactive. Some elements are being more reactive, and as we told in the first point, elements with octet configuration are being least reactive. So why other elements are being reactive? It is explained here. The cause for the chemical reaction is to attain stability. So simply it is told here in a single line. For the complete chemical reactions, the main cause is to attain stability. As we told, our scientists they have discovered so far 118 elements, isn't it? So out of these 118 elements, only very few elements are having this stability, that is octet configuration. whereas remaining all elements, they do not have this octet. So as they do not have octet or duplet configuration, those elements are unstable or more reactive. These unstable and more reactive elements also, they will try to attain the stability. They will try to get a stable configuration. Because of this reason, because of this attainment of stability, trying to attain stability, all these elements will participate in the chemical bond formation, and hence these many crores of compounds are being formed. So for the main cause for the formation of these many compounds is elements they will try to attain stability. Elements they will try to attain stable configuration. Because of this reason, elements will participate in the chemical bond formation and they form numerous of chemical compounds. Okay. So the cause for the chemical reaction is to attain stability. An atom achieves this by acquiring the octet configuration, that is the nearest inert gas configuration in its outermost shell. So to attain this nearest noble gas configuration, all the elements they will try to participate in the chemical bond formation, and thus they will get this configuration. Type of electrons taking part in a chemical reaction or chemical bond. Yes, what type of electrons taking part in the chemical reaction also will responsible for the formation of chemical bonds. The electrons present in the outermost shell of an atom are responsible for the chemical reaction. So this point explains us which type of electrons are participating in the chemical bond. An atom may have so many number of electrons, but the electrons present in the outermost shell of that atom only are responsible for the formation of chemical bonds. These electrons only will participate in the chemical bond. That atom may have so many number of electrons, but out of those all electrons, the electrons present in the outer shell, that is the last shell, those we call as outermost shell, those electrons only will be responsible for the chemical nature of that element, and these electrons only will participate in the chemical bond formation. The outermost shell is called valence shell, and hence the electrons present in it are called valence electrons. So the electrons present in the outermost shell of an element are called valence electrons, because that outermost shell is called valence shell, and hence the electrons that are called valence electrons. The number of electrons taking part in a chemical reaction is called the valency of that element. So the number of electrons from the valence shell, how many electrons are participating in the bond formation, is called its a valency of that element. Suppose you see here one element is shown here. The atom of an element is shown. I think it is argon because it is having 18 electrons. And if you observe in the outermost shell or the last shell of that atom, there are 8 electrons. These electrons present in the outermost shell or valence shell are called valence electrons. There are 8 valence electrons for this atom. So in the valence shell, as there are 8 electrons, this atom is more stable. If any atom, if it is having other than 8 electrons in its valence shell, that atom will be unstable and will be trying to become stable by getting 8 electrons in outermost shell. So because of this, these atoms which are not having 8 electrons will be participate in the chemical bond formation. Okay. Now these valence electrons are responsible for the chemical reactivity of the atom. Atom with 8 valence electrons is stable. The atom with other than 8 electrons in its valence shell will be unstable and more reactive. Next, there are two ways by which the atoms can acquire noble gas configuration or 8 electrons in their outermost energy level. We are telling the atoms which are not having 8 electrons in their outermost shell, they are unstable and they will try to attain 8 electrons in their outermost shell. That is, they will try to attain nearest noble gas configuration. This attainment can be done in two ways. They are either by losing or accepting electrons. This is one way. Some elements they will lose excess of electrons and hence they will attain the octet configuration. And some elements they will gain certain extra electrons from other atoms and hence they will attain octet configuration. That's one way. Either by losing or accepting electrons. The other way is by sharing electrons. By mutual sharing of electrons between one or two or more atoms they will attain octet configuration. So by these two ways, atoms can attain their nearest noble gas configuration in their outermost shells. One it is by losing or accepting electrons, and the second one is by sharing electrons. Okay, so corresponding to the above two ways, but that is by transferring electrons or by sharing electrons. There are mainly three types of bondings or linkages which hold the atoms together in a molecule. So based upon this two ways of the attainment of octet configuration, there are mainly three types of chemical bond formation or chemical linkages which hold the atoms together in the molecules. They are, one it is a electrovalent bond or ionic bond. That is, second one is covalent bond or a sharing bond. And third one, coordinate covalent bond or dative bond. So based upon the way of attainment of stability by the atom, these three kinds of bonds may be formed between the atoms which hold the atoms together in a molecule. One of them is electrovalent bond or ionic bond. Other one is covalent bond. Third one is coordinate covalent bond, which is also called as dative bond. Now, first among them is electrovalent bond or ionic bond. About this, let us see here. Electrovalent bond or ionic bond. The chemical bond formed between two atoms due to transfer of electrons from one atom to another atom is called ionic bond or electrovalent bond. We told some elements they will lose electrons and hence they attain octet configuration, and some other elements they will gain electrons from other elements and hence they attain octet configuration. So in this way between them certain relation occurs, that a certain bond will be formed. That chemical bond formed between two atoms due to the transfer of one or more electrons from one atom to another atom is called ionic bond or electrovalent bond. The electron transfer results in the formation of cations and anions. What are cations here? We know the cations are positively charged ions, whereas anions are negatively charged ions. So the oppositely charged ions are attracted to each other and the bond formed between them is called ionic bond. Let us see here one example. If we see sodium atom and chlorine atom, we know sodium has only one valence electron. And if you see for chlorine, there are 7 valence electrons. Are these two atoms stable now? No. What is the number of electrons to be in the outermost shell to be stable? 8 electrons. But if you see for sodium, there is only one electron outermost shell, because if you see its configuration 2, 8, 1. 2, 8, 1. Isn't it? Now it has only one electron in its outermost shell. So it is not a stable element. If it is not stable element, it will try to become stable by attaining nearest noble gas configuration. So what is the nearest noble gas for sodium? Just before element, that is neon. So to become like neon or to get the near noble gas near neon configuration, sodium will be always ready to lose this one electron. But we have to remember one thing, sodium cannot lose this electron in its own. To lose this electron, there should be another element which accepts this. Then only sodium can lose this electron. It cannot throw that electron, excess electron on its way. There should be another element to accept this electron, and hence then only sodium can lose it. If we see in case of chlorine, we know its configuration 2, 8, 7 because its atomic number is 17 as we know. Now, there are 7 electrons in its valence shell. It is also a not a stable element. And this also will try to attain the stability by gaining one more electron, and hence it will get the nearest noble gas configuration, that is argon configuration, when it will by gaining one electron. So this chlorine will be always ready to gain one more electron from other elements. This can gain electron when other elements are ready to lose it. So when the sodium and chlorine approach each other, what happens? One is ready to lose one electron and the other one is ready to gain that electron. Immediately, this transfer of electron occurs between these two elements. So this electron will be transferred from sodium to chlorine. Now sodium gets the nearest noble gas configuration, that is 2, 8, and at the same time chlorine will get the nearest noble gas configuration, that of argons 2, 8, 8 configuration it will get, because 8 electrons coming now in the valence shell, isn't it? So if you observe, then sodium is losing one electron. By losing of one electron, sodium forms sodium ion, that is Na plus ion, which is called cation. So positive ion is called cation, we know, as by losing one electron sodium forms a cation. At the same time, if you observe at the chlorine is gaining one extra electron. By gaining of electrons, elements they will form negatively charged ions. Cl minus ion is formed, isn't it? Cl minus ion is formed. This is called anion. Chloride ion is called anion. So in this way, two oppositely charged ions are formed. Between these two oppositely charged ions, certain attraction occurs. That attraction formed between the oppositely charged ions, which are formed by the transfer of electrons from one to another. That attraction is called ionic bond. So because of that attraction between these two, these will be held together. That attraction is called here ionic bond. Okay, that is why it is defined as the chemical bond formed between two atoms due to the transfer of one or more electrons from one atom to another atom is called ionic bond, which is also called as electrovalent bond. Okay, the bond existing between the opposite charged ions is also called as electrovalent bond or polar bond. It is also defined as the bond formed by the electrostatic attraction between the opposite positive and negative ions is called ionic bond. So see here how many definitions are given here for the ionic bond formation. So one it is called ionic bond because this bond is existing between the oppositely charged ions. So it is called ionic bond. At the same time, this is formed between the two opposite charged ions, which are formed by the transfer of electrons, electrically charged ions. That is why it is called electrovalent bond also. And even because of this formation between the two oppositely charged ions, it is also called polar bond. Here polar or polarity means charge formation. So it is formed by the two oppositely charged ions. It is formed between the two oppositely charged ions. It is called polar bond also. Okay. See here, sodium and chlorine, they are combining together to form sodium chloride bond. And here, sodium forming a positive ion, whereas chlorine forming negative ion. Oppositely charged ions are formed. Between these two, the attraction occurred is called ionic bond. Compounds containing ionic bonds are called ionic compounds or electrovalent compounds. Even they are also called as polar compounds. Now we can say sodium chloride is an ionic compound because the sodium chloride substance is formed by the transfer of electrons between the sodium atoms and chlorine atoms. So it is an ionic compound or electrovalent compound. Okay. Next, we have to note one point here. Electrovalent bond is not possible between similar atoms. Yes, because if you observe, there should be two different kinds of atoms where one is ready to lose electrons and the other one is ready to gain electrons. For example, if you take sodium atoms, both the sodium atoms, one sodium atom will be ready to lose electron. If you see other sodium atom, it is not at all ready to gain electrons, isn't it? So that sodium atom is also ready to lose electrons only. If both are ready to lose electrons, there is no chance of the formation of ionic bond. What is the requirement for the formation of ionic bond? There should occur transfer of electron. One should lose electrons, one or more, and the other one should be ready to gain those electrons. Then only ionic bond is formed. But if both are of same kind, they cannot form an ionic bond. If you see in case of chlorine atoms, if you see one chlorine atom will be ready to accept electrons. What about other one? Other chlorine atom also will be ready to accept electrons only, but not to lose. So if both are ready to accept electrons, then there is no chance of formation of ionic bond between them. So we can say this electrovalent bond is not possible between two similar atoms. This type of bonding requires two atoms of different nature. That is, one atom should have tendency to lose electrons, one or more. That is, they should be electropositive in nature, like sodium. And the other atom should have tendency to accept electrons, one or more. That means that should be electronegative atom. That should be electronegative in nature. So mostly ionic bond is formed between two different kinds of atoms. These are, one is electropositive and other one is electronegative. That means the atom with electropositivity will lose one or more electrons, and the atom with electronegativity will gain those electrons, and hence they form oppositely charged ions. There is attraction formed between them we call as ionic bond or electrovalent bond. Okay, so actually ionic bond is not a true bond, but just electrostatic force of attraction between closely packed ions. So we can say here ionic bond is just attraction between the oppositely charged ions we're telling. That's why we say it is not actually a true bond. There is no linkage between the atoms. Just because of attraction, they will be held together. That is why we say ionic bond is non-directional bond. If you say example, sodium chloride, we say sodium loses electrons and forms Na plus ions, and chlorine gains electrons and forms negative ions, that is Cl minus ions. In this way, so many positive and negative ions are formed. Between these all ions, there occurs attraction from all the directions. So these attractions we are calling as ionic bond, and hence it exists as a solid form because all together they will be bind together. So for this sodium ion, there will be attraction from so many Cl minus ions from all directions. So this will attract it, this will attract it, this also will attract, and here one more Cl minus ion will be attracting it, and from front and from back. In this way, from all the directions, there will be an attraction on a particular ion from the oppositely charged ions. That is why we say this is there is no particular direction. From all the directions, this force of attraction is occurring. That's why we say electrovalent bonds or ionic bonds are non-directional in nature. There is no fixed direction that may have attraction from all the directions from the opposite charged ions. In the same way, you can say this chlorine ion will be having attraction from all the directions like this, from front, left, right, up, top, and bottom, from all the directions. So we say these ionic bonds are non-directional. Let us see an example, the formation of sodium chloride. Again, the free sodium atom has one valence electron as we know because its atomic number is 11 and its configuration is 2, 8, 1. So it has one valence electron. Whereas the chlorine atom has 7 valence electrons because its atomic number is 17 and its electron configuration is 2, 8, 7. isn't it? So in forming an ionic bond, the sodium atom loses its valence electron, which is accepted by chlorine atom. As a result, sodium achieves noble gas configuration of neon, that is 2,8, and becomes a positive ion, stable positive ion, that is Na+. In other way, chlorine achieves the noble gas configuration of argon, that is 2,8,8, and acquires a negative charge Cl- ion. Now, the attraction between sodium ion and chlorine ion is an ionic bond. Yes, it is attraction. So this attraction won't be the only one opposite ion. That may be with so many number of oppositely charged ions from all the directions. That's why I told this ionic bond is non-directional. So a shorthand way of showing the formation of sodium chloride from sodium and chlorine atoms involves electron dot symbols. So we can represent like this: formation of sodium chloride. So one sodium atom losing one electron, and that is gained by chlorine. So opposite charged ions are formed. This is Na plus ion and this is NCl minus ion. The attraction between these is called ionic bond or electrovalent bond. Okay. We have one more point here, that is in all ionic compounds, the electrons lost by one or more atoms in achieving noble gas configuration of a cation are accepted by a requisite number of companion atoms to achieve noble gas configuration of the anions. So in an ionic compound, the number of electrons lost by one or more positive ions or cations is equal to the number of electrons accepted by those atoms. For example, let us see here formation of sodium oxide. In the formation of sodium oxide, one sodium atom will lose one electron. So here two sodium atoms are there. So both will lose together two electrons because one sodium, each sodium losing one electron. So total together they are losing two electrons. So the same number of electrons are accepted by one oxygen atom. Each oxygen is ready to accept two electrons. So in this way, the electrons from the both the sodium atoms lost will be accepted by one oxygen atom, and hence they form three charged ions. Two positively charged ions are formed by sodium atoms. One negative ion, one anion is formed by oxygen atom. Between these three, attraction occurs, and hence ionic bonds are formed between them. Now we can say ionic compound sodium oxide is formed. Got it? This is about ionic bond formation. So ionic bond is formed by transfer of electrons between the opposite kinds of atoms, electropositive and electronegative atoms. It is non-directional. It is not fixed between two atoms. So these attractions may be from all the directions with oppositely charged ions. Okay. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates and recorded videos.